The overall goal of this procedure is to generate far-infrared laser radiation and to measure the frequencies of the generated laser emissions using a 3-laser heterodyne technique. This is accomplished by first sending carbon dioxide laser radiation into a far-infrared laser cavity. The second step is to vary the operating parameters of both laser cavities to generate far-infrared laser radiation and observe the detected radiation using an oscilloscope. Next, the far-infrared radiation is mixed with 2 reference carbon dioxide laser frequencies. Then the resulting beat frequency is identified. The final step is to measure multiple beat frequencies to calculate the far-infrared laser frequency. Ultimately, during this investigation, the 3-laser heterodyne technique is used to measure 8 far-infrared laser frequencies generated by difluoromethane for the first time.
Though the results from this method can provide insight into the spectroscopy of the lasing molecule, it can also be applied to systems requiring accurate frequencies, such as high-resolution spectroscopy, radio astronomy, and terahertz imaging.
Prepare to work with potentially harmful laser radiation by wearing appropriate eye protection. This part of the protocol will use a carbon dioxide laser and a polished copper far-infrared laser cavity. This schematic provides an overview of how the two are arranged. The carbon dioxide laser will pump the far-infrared laser cavity, which will be filled with difluoromethane for this experiment. The far-infrared laser output will be detected with a metal insulator metal point contact diode detector. Begin by working with the carbon dioxide laser set to a desired laser.